Today we're going to take a look at solving systems of equations. Now there's three ways you can solve systems. You can use the graphing method, substitution method, or the elimination method. We're going to talk about each of these, and they are better suited for different things depending on how it's presented to you. So first off, solutions are ordered pairs. They're the pair x comma y. So you're going to end up solving for an x and then finding the y, or vice versa. You do need both parts. If you go through and you solve and you find that each variable cancels out and you're left with something that is false, like 0 equals 4, that's a no solution, those lines are parallel. So if you're looking at a graph, they'd be two lines that aren't touching or will never touch. If you go through and you're solving it and both cancel out and you're left with a true statement, like 0 equals 0, 5 equals 5, something like that. That is infinitely many or all real number solutions. You'll see it written both ways depending on what you're looking at. So in that case, that just means it's the exact same line. So if I was to graph one line and then I take the second line and graph it, they're going to fall right on top of each other. They're going to share every single point. So that's the background of our solution types. Again, each way, each method has its pros and cons depending on how it's given to you. Okay, so the first one is our graphing method. And it's best if you're given equations already in slope-intercept form, or ideally if you already have graphs visualized for you. So solving by graphing is when you look at lines and you're looking to see where they intersect, if they intersect. Wherever they intersect, that is their solution. That's your point, x comma y. If they do not intersect, we talked about that. That is this over here. It's called an inconsistent graph or an inconsistent system. There's no values there. It is inconsistent. There is no way one's going to be the other or cross the other, I should say. So those are parallel lines. Those are no solutions. If you solve and you get a true statement, like I mentioned before, the all real numbers, that is what we call consistent and dependent. The two lines depend on each other because they're the same. One line graphed directly on top of the other. They share every single point. So they're dependent. That's what we would call that. And those would have all real number solutions. And then the independent one in the middle, that's that first case. If I was to solve, they cross, they're two independent lines. They're each doing their own thing, and one will cross the other at some point, and that is your intersection point. All right, and we can see from the graph next to it, here's two lines. They're independent of each other, doing their own thing, and they meet at the point 2, 3. So that is our graphing method. Our substitution method. Substitution method is best used when you can easily get one of the variables by itself, or if it's already by itself. In that case, you'll just use it and plug it into the other equation and solve for whatever you're left with. So I have two examples here written out. I can see that I have y equals in the first one on that bottom. So I just take what y equals, I plug it into the y in the other equation. You have to go into the other one. You don't want to plug it into itself. And then I solve it, and you can see how I solved here. We got x equals 5. I then plugged it back in, and you can plug it into either one. I chose to plug it into the y equals equation, and I got -1, and that is my ordered pair. Again, make sure you're writing your ordered pairs x comma y. In the second problem, same thing. This time I had an x already by itself, so I took what it equaled, plugged it in, and then I went through and solved it. Now in this case, when I solved it, my y's ended up canceling. They're on the same side. One's a +4, one's a -4. They canceled out. I was left with -6 equals 9. -6 will never equal 9. That is a no solution. Okay, and then the last method is our elimination method. This one a little bit more lengthier. You want to make sure they're in standard form. So the goal is to have them letters on the left, constants on the right, and you want to cancel out or eliminate one of the variables. So ideally, if they're already the same value, like in the first one, 2x and 2x, you're just going to subtract down to get those two x's to eliminate, and then you solve with what you're left with. And then same thing we did in substitution. Once you find one variable, plug it back in, find the other. And I forgot to write it in there, but you would have that -1 in that position. And in this case, the second one, I don't have either my x's or my y's that are identical. One's a 3x, one's an x, one's a 6y, one's a 2y, or negatives. They're not the same. They're not going to cancel. So I need to create them to be the same. Well, the easiest in this case is to take the x on the bottom and times it by 3. Now I'll have identical values, but what I do to one, I have to do to all. So that's why you'll see this bottom row is changed. And now my x's will cancel when I subtract. In doing so, my y's also canceled and my constants canceled. I was left with 0 equals 0. That's a true statement. 0 will always equal 0. It is all real numbers. Okay, and this would be that dependent line. If I was to graph them, they would come up on the same line. Okay, so they would share all their points. So I'm going to go through 3 word problems with you. We're going to use substitution and elimination method. Not going to use graphing as much. Like I said, ideally, it's best for when you already have a graph and you're looking at it. If I don't have to graph, I'm not going to. I'm going to save myself time with that. Okay, so let's exit out of this. All right, so in this question, I've already highlighted all the important things, but if you read through it, we have a math test that is worth 100 points. We have 38 problems. Each problem is worth either 5 points or 2 points. And we want to figure out how many problems of each are on the test. So what I like to do is I figure out totals first. If I have totals, great. I know those are going to go at the end of my problems. And I'm talking about 2 different things, right? I'm talking about points, point values, and I'm talking about problems, number of questions on the page. Okay, so when I set this up, I know I have 100 total points. Right, and I have 38 total questions on the test. So those are going to be my totals. I'm just going to put them at the end. And then from there, I'm going to set up the rest of it. Points, 5 points, 2 points. Those are 2 different things. So I'm going to use my 2 variables. I'm going to use x and y. I have 5 points plus 2 points times however many questions each of them have has to equal my 100 total points. Now, the x and the y represent how many how many questions are associated with each point value. So I have x amount of questions plus y amount of questions has to equal the total amount of questions, is my 38. Now from here, I can choose to either solve by substitution or elimination. Both of them are fairly easy. I'm going to just do a substitution problem here because I can really easily take this bottom equation and change it. So if I wanted to get the y by itself, all I would have to do is subtract the x on both sides. And you could have also gotten the x by itself if that's what you chose that you wanted to do. Okay, once I have what it equals, I'm going to take this y value and I'm going to put it in the y value in the other equation. Okay, so I can rewrite this top equation as 5x plus 2y. And instead of y, I'm putting in a negative x plus 38 because that's what I found that it equaled. And that's going to equal 100. Okay, from here, I'm going to solve it. I'm going to distribute that 2 in. So negative 2x, 2 times 38 is 76, equals 100. All right. And then again, I would solve what I could here. So I would combine the 5x and the 2 because they're on the same side. That gives me 3x. All right, I'll subtract those 76 over, get 24. So x equals 8. at this point. Once I know 8, I'm going to plug it back in to, I'm going to choose this y equals, just makes it easier. You could plug it in anywhere if you want to go back to the originals. And then y equals 30. Now, if this was a graph or just two regular problems, the point would be 8, 30. This is a word problem though, so we want to have word answers and explain what they mean. So the X was our 5-point questions, right? X was attached to the 5 up here. So there are 8 5-point questions. And then 30, that was attached to the 2y. So there are 30 2-point questions on the test. I want to stress word problems need word answers. So do not leave them as an ordered pair. Word problems, make sure I have answers with words in it. Okay. All right. So that's an example of your substitution. If I jump to the second one, here's one that we can use of, we'll do elimination with this one, I think. So here we got X dollars for individual songs. So they're already telling us the variables to use. Y dollars for entire albums. Person A is paying $25.92 to download 6 individual songs and 2 albums. Person B is paying $33.93 to download 4 songs and 3 albums. So we've already split it into 2 equations already. We got person A and person B. Those are my 2 categories, my 2 equations I'm going to use. So I can create these really quick and easy. I already know individual songs are X, Y are my albums. So total was $25.92. We have 6 songs, so that's 6X, and 2 albums, so 2Y. So that's person A's total. And then person B paid $33.93, and they had 4 songs and 3 albums. Okay, so now when I look at these problems, I mean, I could, if I wanted to, get X and Y by itself, but they're going to cause a little bit more work. I want to go with the least amount of work. So I can easily take one of these equations and transform it, or I could take both of them and transform it. And I'm going to do both. I'm going to look at my problems. This is how I come up with my eliminations. I look at my X's and I look at my Y's. I like to use smaller numbers if I can. So the smaller numbers are in the Y spot. Again, you can do the same thing I'm about to do with the X's if you choose to. And I'm going to take their coefficients and I'm going to multiply the other problem by the coefficient. So the top row, I'm going to multiply everything by 3 because that's in the bottom. And I'm going to multiply the bottom row by 2 because that was the coefficient of the top. By doing that, I am forcing it to have the exact same equations set up, the exact same number of coefficients. Okay, so when I multiply those out, I get 18x plus 6y equals 77 and 76 cents. And the bottom row becomes 8x plus 6y equals $67.86. Now, again, when I go back and I look, there's my y's, and they are identical. So as long as they're identical, I can subtract them. And I'm going to subtract everything. Get those to cancel. And then do the rest of the problem. 18x minus 8x is 10x. 77, 76 minus 67, 86 is $9.90. And when I divide, I get 0.99. Again, I'm going to take that, plug it back in. You can plug it anywhere you want. I'm going to just plug it into the top equation. Oops. Okay. We know our x. X is 99 cents. And now we're solving for our y. So 6 times 99 is 594. And again, it's just a matter of solving from here. And if you need to show all the work, show all the work. If you don't, that's okay. I do need to see some. I need to see the plugged in and simplifying as best you can. I would subtract 594. When I do that from 2592, it's 1998. And y equals 999. Again, if this was an ordered pair, if this was a graph, this would be my ordered pair. And this is partly why graphs aren't always the best. You would never come up with that on a graph. You would visually not see it. You would think it were whole numbers. And if you round it, now you're getting wrong values. So again, it's a word problem, word answers. So I'm going to answer this as individual songs cost 99 cents, and albums cost $9.99. Okay, so again, when you work through these, you have the two options. It's up to you. Make sure you read word problems carefully. If I just gave you the setups, should be okay, but you do want to know how to analyze them as well. Okay, any questions, you know to reach out for me.